Okay, good day friends. Right now let's try to solve this problem number 4. A ball is given an initial velocity at point 0 under some angle to the horizontal. The ball moves in a space bounded by two parallel vertical walls separated by distance L. Under what angle to the horizontal must the ball be thrown so that it returns to point O? It arrives at point L where the second board is located. So basically this would be the picture for our problem, and before we start I need to note that we might have two answers because there are also complementary angles. Yeah, right now we're going to work with angles. So basically I will tell you a little bit more about this at the end, but for right now let me write it something like this. Yeah, this would be our angle alpha. Yeah, and our ball is thrown to the wall and it bounces several times. We don't know how much, and at the end our result must be something like this. If we work on the A option, it must return to this point O. If we work on option B, it must return to point L. Okay, something interesting about this problem is that we're not told how many times it bounces. That's why we need to derive our own formula, so it was universal for all of the situations, right? Okay, so basically we have such kind of situation. Yeah, what we can do is just apply this formula, which is the basic kinematic equation. Let me write it down here. Delta x equals the initial time plus 1 divided by 2 at squared. Of course, if there is a force, there would be acceleration. If there is no force, there is no acceleration. Okay, right? Okay, first of all, we need to look at vertical result. Why? Because it's easier. And if you ask me why, the thing is, no matter how we start, no matter how we end, our final result, yeah, would be just ending at the same height. Why? Because this ball is thrown here, then here, then here, then here, goes back, 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 and, oh, I'm sorry, it just ends up at the very beginning. Or let's say it just bounces like this, and ends up at the L. But the height is the same, so there is no change in height. Our delta x, yeah, in y direction is just 0. It doesn't change. Okay, so our vertical component of the initial, of course, it's v sine alpha, definitely vi sine alpha, because we know how to work with alpha. Yeah, if we have something like this with angle alpha, then we have two components. The adjacent line would be cosine, and the opposite one would be just sine alpha. Okay, so this is the basic geometry stuff. Right now let's return to physics. Okay, so we have here unknown time, let's say just t, and what? Do we have some forces acting vertically? Of course we do. Yeah, it's weight. So if there is a force acting vertically, it means there is acceleration vertically, but it is downward because this is gravity, and it must be minus all the time. Okay, yeah. What can we do? Yeah, we can just move this thing in here, and we would have something just the initial sine alpha t equals 1 divided by 2 gt squared, and we can just cancel one of the times, and then we've got what? Yeah, basically we can just derive the formula for time, but right now let's leave it like this. Yeah, let's work with vertical, with horizontal axis, I'm sorry, and this would be a little bit more interesting. Here we can have two cases. Yeah, that's why let me write it with two cases. I would take something a little bit thicker, and let me choose the red one. We need to write this thing, A option, end up in O. Okay, we need to end up in O position. Let's write B option, end up in L. Okay, so, okay, yeah, I like it. So right now we have two options. This thing works in both situations because both of them are in zero difference in the height, and it's still the initial sine alpha t minus gt squared in both situations. It doesn't matter, it's just universal, right? Let me even highlight it like this. Yeah, it works in both situations. However, horizontal would be a little bit different. Okay, so if we need to end up in O, what we need to do? In fact, we have to move some path L and go back. But we don't know how many times, right? We need to, but what we know, this amount has to be multiplied by 2. Yeah, 2x. Why? Because all of our bouncings must be doubled in order to, yeah, we need to hit the L side wall and then go back into O position, right? At least one bouncing in order to get back. We need to make 2 L's in order to go to the O position, right? At least. But we can go even more and more and more, something like this, like here, 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 right? So we can do many bouncings. It doesn't matter. The most important thing is it must be 2x, right? It must be even number. Okay, so how do we write the formula for even number? It would be just, let's write just 2kl. Yeah, why not? This k shows just the number. Yeah, k can be anything. Let me write it something like this. K might be 0, 1, 2, 3, 4, 5, 6, yeah, and so on. It doesn't matter. So we can put in k any number we want. But whatever we do, whatever we put into k, it would be always multiplied into 2. That's why it will become just even number of l's. That makes it to end up in O. That's good. Okay, the logic is right. Equals v cosine alpha. Yeah, we do know it, as we've told it before. Cosine alpha and t. Right. No forces acting horizontally. There is no acceleration. Okay, so right now we can just write the formula for t, right? It would be just t equals 2vi sine alpha divided by g. Okay, we can apply this thing in both situations. Okay, yeah, this is the universal thing. I can just take this off. It's not important anymore. The most important thing is this one. Okay, here I have this t, and I have to put it inside. Yeah, it would be just 2kl equals vi cosine alpha, and instead of t, I just put 2vi sine alpha. 2vi sine alpha. Yeah, and we have also divided by g. We must not forget about it. What you can see here is very interesting. vi, and also 2 sine alpha, cosine alpha. Okay, what it gives us is something very interesting. Is just 2kl equals vi multiplied by vi is just vi squared. 2 sine alpha and cosine alpha gives us sine 2 alpha, right? Divided by g. And what we were asked is under what angle to the horizontal must the ball be thrown? So what we need to find is angle. We need to find alpha, okay? So in order to find alpha, we need to leave this sine alpha alone, and it would be just something like this. Sine 2 alpha, it would be 2kgl divided by vi, right? Nothing else. Vi squared. Okay, yeah, I like it. And just we need to make it 2 alpha equals arc sine. Let me write it like this, arc sine. And inside we just put 2kgl divided by vi squared. Okay, and our alpha would be just 1 divided by 2, yeah, arc sine. And this thing again. Yeah, so that would be our answer. Yeah, I like it. This would be our answer for this situation. And what else? Let's look at this situation. What do we need in order to end up in L? What we need is that we need to have the same thing, but in odd number. Why? Because, for example, we need to go there just one time. Or if we go there, back, we need to go for the third time. Or if we go back again, we need to go for the fifth time. So this number of the bouncings have to be, not number of bouncings, but the number of L's, how many L's we move, has to be always odd. And we know the formula for the odd. It's just simple. It's something like this. Yeah. Let me write it something like this. It's probably the same thing, but I would write it something like this. 2k plus 1. This would be the formula for, yeah, as you can see here, this is 2kl. If I put here something like 1, it would be 2. If I put 2, it would be 4. 3, 6. 4, 8. It would always be odd. Even, I'm sorry. Here, it would always be odd. If I put, instead of k, 0, it would be 1. If I put 1, it would be 3, right? If I put 2, it would be 5. If I put 3, it would be 7. Okay. This is correct logically, and the same thing, vi cosine alpha time, and there is no any forces acting horizontally, and that's why no acceleration. We can put the very same thing. It would be basically the very same thing. Yeah, that's why I would just take this thing, just copy it, put here, and yeah, basically what is happening is that this part, as you can see, yeah, let me just highlight, this part and this part is totally the same. That's why what I mean by this, we can just totally copy that paths. It would be the same thing. Yeah, if you don't believe me, you can just try it yourself, but I would just take all these things and copy. Yeah, I would just take this and copy it right in here. Yeah, let me just take it a little bit here, take it a little bit here, right? And this thing is the only thing that is been changing for entire process. Yeah, okay, yeah, in here it would be sine 2 alpha, right? Sine 2 alpha. Sine 2 alpha. Okay, and instead of 2kgl, it would be what? It would be 2k plus 1 L, yeah, gl divided by v initial squared. Yeah. If in this situation we had 2k GL, in this situation we have 2k plus 1 GL. This is important because only thing that is been changing is only this thing and this thing, which shows us that how many L's we need to move, the odd number or the even number. Anything else is just the same logic. And yeah, we can just write here, straight just alpha equals 1 divided by 2 arcsine and this thing, 2k plus 1 GL divided by VI squared and in brackets. Okay, that's good. That's the answer, what we need. However, as I've said before, we might have something called complementary, right? So what is that complementary thing? The thing is this, as you can see here, sine theta equals sine p minus theta. Yeah, you can just prove it by basic trigonometry rule, which is sine alpha minus beta gives us just sine p cosine theta minus cosine p sine theta, right? And sine p just gives us 0, that annihilates all of this part, and cosine p gives us -1, but we have minus in here, it gives us 1, and sine theta equals to sine theta. This rule works. So what it means is that the complementary, the another side, still works. So for example, let's look at this situation. We have such kind of situation. The angle might be small, something like this, right? It might be small, or it could be large. It could be different angle, something like this. Let me throw it something like here, and then here, 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 right? So it could be at the same time a small angle which goes like this, or something which goes like this, right? So the angle might be as small as big. That's why we need to apply this formula. It would be our one more answer, and that's why we need to apply this thing as well. Oops. Sine p minus 2 alpha, yeah, equals this thing. Yeah, let me just copy it. Let me just take it, oops, and put it just right here. Yeah, that would be good. And if we just take it, it would be p minus 2 alpha equals arcsine, arcsine in brackets, put all this stuff inside of the brackets. And yeah, and then what we need is put p another side. It would be just something like minus 2 alpha, and p goes there, would be negative, like minus p plus arcsine. And this thing, yeah, let me call it just x, it doesn't matter. This entire thing, I mean this thing, is this small x. Yeah, I don't just want to write it all the time, but we can just change this minus and this minus. We can make it just positive from both sides. If we multiply by -1, it would be just 2 alpha equals p minus arcsine, this x, yeah, and just equals p divided by 2 minus 1 divided by 2 arcsine, again, arcsine. Yeah, and inside of x right now, let me just write this thing. Yeah, so this would be another answer, and this is still true for our problem. Yeah, this is another answer for our problem, and all these answers would be correct. Okay, thanks for your attention. Basically, this is not much hard problem. In fact, we just applied one formula, again, just applied it vertically, applied it horizontally, just 2 times. But the only thing that we really need is just to understand how much times it has to cover L. Yeah, we cannot just use O, because O is not distance. O is just the point, it's the position. But L is the paths, okay, to cover. That's why how many L's we need to cover. It might be just 2k plus 1 in order to make it or odd number, or just 2k in order to make it even number. Okay, so thanks for your attention. If you watched it till this time, I am happy, to be honest. And if you didn't understand some things, you could write me privately. Yeah. Thanks for your attention. Goodbye.